In question number 1, we have to solve the equation e power x plus 2 e power minus x upon e power x minus 3 equals to 4. So in the first step, we can just simply cross multiply. We'll get e power x plus 2 e to the power x is equals to 4 e power x minus 12. Now we can write this as e power x plus 2 upon e to the power x is equals to 4 e power x minus 12. Now we can take a substitution. So let's say we write y is equals to e power x. We can write the equation as y upon 2 upon y equals to 4y minus 12. Taking the LCM, we'll get y square plus 2 upon y equals to 4y minus 12. Now cross multiplying, we'll get y squared plus 2 is equals to 4y squared minus 12y. Then bringing y squared on the right hand side. So 4y squared minus 5 squared, that will be 3y squared minus 12y, and plus 2 will become minus 2 equals to 0. Now solving this quadratic equation using the quadratic formula. So we'll get y is equals to, it's minus b. So this will become plus 12 plus minus b squared. So 12 squared minus 4 into 3 into minus 2. 4ac upon 2 into 3. Now it's very important that we show the working over here for the quadratic equation, as there's a mark uh, in the exam for showing the working for finding the roots of this equation. So now once we have shown this, now we can substitute this into the calculator. So we'll get 144 plus 24. So 12, and then we'll square root the value. We'll get 12.96. So we'll get 12 plus minus 12.96 divided by 6. Now, with y is equals to e power x, y has to be a positive value. A negative value is not possible. So what we'll have is y is equals to 12 plus 12.96 divided by 6. So we'll get 12 plus 12.96 divided by 6. That is equals to 4.16. So y would be is equals to 4.16. And finally, we know that e power x is equals to y. So we can write e power x equals to 4.16. Introducing ln on both the sides, we'll get x ln e is equals to ln of 4.16. Substituting this in the calculator, we'll get 1.4255. So x would be is equals to 1.4255. And as we have to give our answer to 3 decimal place, so the final answer will be 1.42426. In question number 2, it is given that 2 ln p plus ln of p minus 1 minus half ln q plus 1 equals to 3. We have to find q in terms of p. Now to do that, first we'll write the whole equation in terms of ln and then simplify it. So in the first step, we can write this as ln of p squared plus ln of p minus 1 minus ln of q plus 1 to the power of half. And we can write this as 3 ln of e, as ln of e is 1. Now we'll simplify it using logarithms rule. So when it's adding, we multiply. So p square will multiply by p minus 1, and q plus 1 to the power half, as it's negative, it will be in the division sign, equals to ln of e to the power of 3. We can write 3 in the power now. Now we can equate both the sides. So we can write this as p cube minus p upon q plus 1 to the power of 1 upon 2 is equals to ln e to the power of, or is equals to e to the power of 3, as we compare this with this. Now, as we have to make q our subject, so first we'll bring q plus 1 on the left hand side. We can write it as p cube minus p divided by e to the power 3 is equals to q plus 1 to the power of half. Now taking square root on both the sides, or whole square both the sides, as this is square root, so we'll whole square both the sides to cancel the square root, and this will become p cube minus p upon e power 3 whole squared is equals to q plus 1. We have to give q in terms of p. Now simply we'll just bring 1 on the other side, and we can expand this side if you want. This will become p power 6 as we'll also we'll apply a square minus 2ab plus b squared minus this will become 2p to the power of 4 plus p squared upon e to the power of 6, and then one will subtract over here and that will be equals to q, and this will become the subject. This would be the final answer. In question 3, we have to find the complex number z for which z plus 5 iota upon z minus 5 is real and the modulus of z is root 17, giving an answer in the form z equals to x plus iota y. Now, it says that this is real. It means that the imaginary value will be equal to 0. So the first thing we can do is we'll write, in place of z, we can write x plus iota y plus 5 iota divided by x plus iota y minus 5. Now we'll have to take the conjugate first, but let's, in the denominator, first let's bring the real terms together. So let's write x minus y 5 over here plus iota y, and the numerator remains the same. Now we'll multiply by changing the sign of the denominator. So we'll multiply, let's say, let's keep this as x minus 5 as it is, and let's change the sign of uh, the imaginary value. So this will become minus iota y divided by x minus 5 minus iota y. Now first multiplying in the numerator, what we'll get is, so x times x will become x squared. So x times x is x squared over here. And then x times 5 will become minus 5x. And then x times minus iota y will be minus xy iota. Then iota y into x will become plus xy iota. Iota y into minus 5 will be minus 5y iota. And then iota y into iota y will become minus iota square y square. Iota square is minus 1, so that will become plus y squared. And then finally multiplying 5 iota by x, we'll get 5 iota x minus 25 iota, and then minus 5 iota square y, so that will become plus 5y divided by, so we'll apply the identity. Let's say this is a and this is b, so this will be a and minus b. So we'll have a square minus b square, so this will become x square minus 25, and then plus minus iota square y square, so that will become plus y squared. Now, as we already know that the imaginary term is 0, so let's take the imaginary term separately. So the imaginary terms minus x5 and this will cancel out. We'll have minus 5y iota plus 5 iota minus 25 iota, and we'll be dividing both the real value and the imaginary value by the denominator. And as we know that there is the imaginary value is 0, so we'll put it equal to 0. Cross multiplying, this becomes a 0, so we'll get uh 5 minus 5y iota plus 5 iota minus 25 iota equals to 0. Now the coefficient iota, it is minus 5y plus, and this was this should have been 5x over here. So uh did we make a mistake? Let's quickly check it out. So when we multiply by 5 iota x, yeah, 5, this should have been 5 iota x over here. So this would have been 5 iota x, and this would also be an x over here. So this will become plus 5x minus 25 equals to 0. Now, taking this coefficient as equals to 0, and we can just simply divide by 5 as well, we'll get minus y plus x is equals to positive 25, or x minus y equals to 25. Now, what we also know is that the modulus of z is 17. So the modulus of any complex number is given by x square plus y square, and that is equals to 17. We can take x is equals to 25 plus y. Okay, so 25 divided by 5, that would have been 5 as well. So this will become 5 over here, and this will be, x will be equals to 5 plus y. So in place of x, we'll substitute and this is square root of 17. So this will become x squared plus 5 plus y. In place of x, we'll write 5 plus y. So this will become 5 plus y whole squared plus y squared square root equals to square root of 17. Cancelling out the square root, we'll get 25 plus 10y plus y squared equals to 17. So we have a quadratic term over here, that is 2y squared plus 10y, and 25 minus 17, that will become a plus 8 equals to 0. Factorizing this, we'll get 2y squared plus 8y plus 2y plus 8 equals to 0. Taking common, we'll get y plus 4 plus 2 into y plus 4 equals to 0. So the two values of y will be equals to minus 4 and y would be equals to minus 2. Now once we have the values of y, we can easily find the value of x. We know that x is equals to 5 plus y, or we can also say that, so when x is equals to 5 plus y, the value of y is minus 4. So 5 minus 4, x will be equals to 1, and this x y value is minus 1. And then x is equals to 5 minus 1, so that will be equals to 4. So x is the real value. One of the values for z, the complex number, will be 1 minus 4 iota, and the other will be, so this is 4 and the complex value is minus 1, so this will become 4 minus iota. In question number 4, the parametric equations of a curve are x equals to e tan t, y equals to 3 tan square t. We have to find the equation of the tangent to the curve at the point e comma 3, giving the answer in the form y equals to mx plus c, where m and c are exact. Now to find the equation of a tangent or any line, we need a point and the gradient. To find the gradient, we'll find the dy dx as it represents the gradient of the tangent. So the dy dx would be equals to, so we have y and we have x over here in terms of t, so that we'll write it as dy dt divided by dx by dt. So in the first step, we'll find, so we already have x is equals to e to the power tan of t. So dx by dt would be, so when we differentiate an exponential term, we differentiate the power. So the derivative of tan is sec square. So we write sec square of t into e to the power tan t. And y is equals to 3 tan square t. Dy by dt will be equals to, so the power multiplies over here, that will become 6. The power reduces by 1, so 6 tan t, and the derivative of tan is 6 square t. Now dividing dy dt by dx by dt, we get 6 tan t multiplied by 6 square t divided by 6 square t e to the power of tan t. 6 square and 6 square cancels out. Now this is the expression for dy by dx. Now, once you have the expression for dy by dx, we can just simply substitute the x value over here. But as we do not have the x value, in dy by dx, we have it in terms of t. So what we can do is, we know that x is equals to e to the power of tan t. So in place of x, we can write e over here. So this will be e is equals to, or to make it simpler for us, we can write e to the power of 1 is equals to e to the power of tan t. So we can say now that 1 is equals to tan t, and we can find the value of t as, so t would be is equals to tan inverse of 1. And tan inverse of 1 is pi upon 4. So tan inverse of 1 is pi upon 4 or 45. So we can write t is equals to pi by 4. And once we have the value of t over here, we can substitute in place of dy by dx. So this will become 6 into tan of pi by 4. But again, tan t we could have just written is equals to 1. So we can just write 6 into 1 divided by 1 into e to the power of 1. So this is dy by dx. We can write it as 6 upon e. Now to find the equation, we can just simply use y minus y1 equals to m into x minus x1. Y1 value is 3, so we'll get y minus 3 is equals to m, which is 6 upon e into x minus, and x value is e. Simplifying, we'll get 6 upon Ex minus 6 upon E into E would be minus 6 plus 3. So the equation of the tangent would be 6 upon Ex minus 3. In question number 5, the polynomial is denoted by f of x, where p, q, and a are constants. When f of x is divided by x plus 2a, the remainder is minus 22a cube. When it's divided by 3x minus a, the remainder is minus a cube. We have to find the values of p and q. Now, when it is divided by x plus 2a, that means we will write x is equals to minus 2a and substitute it into the function. So in place of x, we will write minus 2a. So it will become 3 into minus 2a whole cube plus p into a into x again will be minus 2a whole squared plus 7a squared into minus 2a plus qa cube, and this is equals to minus 22a cube. Simplifying this, so this will become minus 8a cube multiplied by 3. That will become 24a cube with the negative sign. This will become plus 4a square. So this will become plus 4pa cube. This will become minus 14a cube plus qa cube is equals to minus 22a cube. Now we can see that a cube is common in all of the terms. We can just take a cube common out and simplify this as minus 24 plus 4p minus 14 plus q equals to minus 22. And we can simplify this as well to make a first equation, and that would be equals to, so 4p plus q, we can leave it on one side. So 4p plus q will be equals to minus 22 plus 14 and plus 24. So 4p plus q, so minus 22 plus 14 is minus 8, minus 8 plus 24 would be plus 16. So this will be our first equation. Now we are also given that when it's divided by 3x minus a, so 3x minus a, will put it as 0. So x would be equals to a upon 3. Now in the same function, we'll substitute x is equals to a upon 3. So this will become 3 into a upon 3 whole cube plus p a into a upon 3 whole squared plus 7a squared into a upon 3 plus qa cube, and the result is equals to minus a cube. Simplifying this, we'll get 3 into a cube upon 27 plus pa cube upon 9 plus 7a cube upon 3 plus qa cube equals to minus a cube. Now, just for clarity, we had AQ over here as well, so it cancelled out in on both the sides. So similarly over here, if we take a cube common out, we can first simplify this as well. So this will become upon 9. So if we take a cube common out over here, we'll get 1 upon 9 plus p upon 9 plus 7 upon 3 plus q, and that would be equals to, so if we take, if you have minus a cube over here, it will cancel out and it will be equals to minus 1. So we'll get 1 upon 9 plus p upon 9 plus 7 upon 3 plus q equals to minus 1. We can simply take the LCM as 9 over here. So this will become 1 plus p plus, so this will multiply by 3. So this will become 7 times c 21. This will multiply by 9. This will become 9q equals to minus 1. Simplifying, we'll get p plus 9q is equals to minus 9. And then this will become minus 21 and minus 1. So finally, our second equation would be p plus 9q equals to minus 31. Now we can solve these two equations simultaneously. The first equation was 4p plus q. 4p plus q equals to positive 16. We can simply multiply this equation by 4 and this by 1. We can multiply by minus 4. So this will become minus 4p plus 36q equals to 31 times 4 would be minus 124. So 4p and minus 4p will cancel out. This will become minus. So this, when you multiply it by minus, this would have become a minus. And this would become a plus over here. So we'll get q minus 36. Q is minus 35. Q is equals to 140. So 140 divided by minus 35 would be equals to minus 4. Now, once we have the value of q, we can easily find the value of p by substituting it into any of the equations. We have the first equation as 4p plus q equals to 16. Q is minus 4, so 4p minus 4 equals to 16. 4p equals to 20. The value of p would be equals to 5. So the values of p, we can finally write it as p equals to 5 and q equals to minus 4. In question number 6, it is given that z1 is 3 e power 1 upon 4 pi, z2 is 3 upon 2 e power of 1 upon 6 pi, and omega is 2 e power 1 upon 2 pi iota. We have to state the values of wz1 and wz2, giving our answer in the form r to the power e iota theta. Now, what we are supposed to know is that when we multiply two complex numbers, the modulus multiplies directly. So this, when we multiply omega by z1, so this will multiply 3 times 2. So omega z1 would be 3 times 2 is 6. And the powers of e, they add up as the angles add up when we are multiplying. Or in simple terms, if you have power e power x into e power y, it becomes e power x plus y. So this will become e to the power of 1 upon 4 pi plus 1 upon 2 pi iota. And we can simplify it down and write it as 6 e to the power. So when you take the LCM or put it in the calculator, this will become 2 plus 1, 3. So 3 upon 4 pi iota. And WZ2 would be, so Z2 is 3 upon 2. So 3 upon 2 into 2 would be 3 in, into e to the power of, this will become 1 upon 6 pi plus 1 upon 2 pi iota. And the final answer would be, so multiplying this by 3, we'll get 3 e to the power 3 plus 1 is 4. So 4 upon 6 pi iota, or we can also simplify it and write it as 3 e to the power of 2 upon 3 pi iota. Now in part B, we have to sketch an Iogan diagram with origin O showing the points A, B, C, and D representing the complex numbers Z1, Z2, omega Z1 and omega Z2 respectively. So first let's make the X and the Y axis over here. Now starting with Z1, Z1 has a magnitude of 3 and the direction is positive 1 upon 4 pi. So we'll just, let's say roughly this is 1 upon 4 pi and let's say this length is 3. So this will represent Z1 or point A and this angle would be 1 upon 4 pi. Z2 is 3 upon 2, so the magnitude is 1.5, so it will be half of A and the angle is 1 upon 6 pi. So 1 upon 6 pi, if you think about it in terms of degrees, that is 30 and 1 upon 4 pi is 45. So Z2 would be over here, half the magnitude of A and this angle would be, so this point would be B and this angle over here would be 1 upon 6 pi. Omega z1 is 6 and the angle is 3 upon 4 pi. 3 upon 4 pi in terms of degrees if you want to think. So that would be 135 or it would be exactly going over here in between with the magnitude of 6. So let's say this point would be C. This will be 6 and this angle over here would be 1 upon 4 pi as this total angle over here is 3 upon 4 pi. And finally, D has a magnitude of 3. So it is in the same direction as A, WZ2. And also it has, the angle is 2 upon 3 pi. So 2 upon 3 pi is 120 degrees. So it would be in this direction, D would be, it will have a magnitude of 3. And this total angle would be 2 upon 3 pi. So we'll just write the magnitude over here, and this angle in terms of degrees would be 1 upon 6 pi, or the total angle would be 2 upon 3 pi. Now it says state the geometric effects of multiplying z1 and z2 by omega. Now one effect we can see directly is that when we multiply omega by z1, we added the angle 1 upon 2 pi, which is basically 90 degrees. So we can say, let's say when we multiplied omega by z1, so this was z1 over here. So this angle over here is basically a right angle. So we can say one of the effects is that it is a, so the point has rotated 90 degrees and it has rotated clockwise as the angle is positive. So the angle would be anti-clockwise. And as for point B, it has also rotated the same. But what we can also add is that when we multiplied A by C, the length became double. So we can say it was also an enlargement. The length became double, so enlargement of scale factor 2. And as for Z2, we can say the same. There was a rotation 90 degrees. It was anti-clockwise. And in this case, for B, the original magnitude was 3 upon 2, and now it's 3, so it became double. So we can say the enlargement was scale factor. So again, the scale factor was 2. So this is a geometric effect of multiplying Z1 and Z2 by omega. In question number 7, we have to express 5 sine x plus 1 upon 6 pi minus 4 cos x in the form r sine x minus alpha. We have to state the exact value of r and give the value of alpha correct to 3 decimal places. Now, to in the first step, we'll have to expand sine of x plus 1 upon 6 pi. The formula, it's given in the formula sheet as well. That's sine a cos b plus cos a sine b. So we can write this as 5 and bracket sine x cos 1 upon 6 pi plus cos x sine of 1 upon 6 pi minus 4 cos x. Now multiplying, we'll get 5 sine and cos of 1 upon 6 pi. If we substitute this in the calculator, that is equals to root 3 by 2. So we'll get 5 sine, or 5 into root 3 by 2 first. So 5 root 3 by 2 sine x, and sine 1 upon 6 pi is half. So that will be 5 into half will be 5 upon 2 cos of x minus 4 cos of x. And we can just write it as C as well to save our time. Now, taking the LCM over here, we'll multiply this by 2. We'll get 5 root 3 upon 2 sine, and this will become plus 5 minus 8 would be minus 3. So this will become minus 3 upon 2, minus 3 upon 2 cos. Now, once we have our expression in this form, we know we can find r, that is equals to a squared plus b squared. So if we have a sine of x plus b cos of x, r is equals to a square plus b square. For revision, you can check the lessons on each of these topics, and you will get to know the basics behind how to convert or how to expand the expression, or to write a sin x plus b cos x in the form r. So we write it as r of sine of x plus alpha or minus alpha, and similarly r of cos x plus minus alpha. So r would be equals to square root of 5 root 3 upon 2 whole squared, plus b is minus 3 by 2, but as it's a whole square, it will cancel out. Simplifying this, we'll get, so 5 square is 25 into root 3 square is 3 upon 4, plus this will become 9 upon 4. So 75 plus 9, that would be equals to 84 upon 4 square root. 84 upon 4 is root of 21. Now, once we have the value of r, we also need the value of alpha over here. So alpha would be equals to tan inverse of b upon a. the b value is minus 3 by 2. So that now what we also know is this. So this is minus 3 by 2 or minus 1.5 divided by 5 root 3 upon 2. Substituting this in the calculator. So, and making sure our calculator is in radian mode. So we'll get shift tan inverse of minus 1.5, and then we divide it by, in the denominator we have 5 root 3, and this, okay, so there's also, it is 5 root 3 divided by 2, and the answer is minus 0.333. So alpha would be equals to minus 0.333. It is 0.3334, but we have to give it in three decimal places, so that would be minus 0.333. And as we have to give this alpha, well, normally we do not use a negative sign over here, so we'll just give the positive value over here. So the final value of alpha would be is equals to 0.333, as we already have a negative sign over here. So the final answer would be root 21 into, and this would be sine of x minus 0.333. Now in part B, it says, hence solve the equation 5 sine of 2 theta plus 1 upon 6 pi minus 4 cos 2 theta is equals to root 7 from 0 theta is 0 to pi. Now we know that this expression can be converted to this form, but the only difference we have to observe over here is that this is 2 theta over here and it was just x or theta over here. So we'll just change the expression, write it as root 21 sine of, and instead of x, we will write 2x. So for this whole expression, we'll write 2x minus 0.333 equals to root of 7. So for in the first step, we'll bring root 21 on the other side. We'll get sine of 2x minus 0.333 equals to root 7 upon 21. That would be equals to root 1 upon 3. And then 2x minus 0.333 would be equals to sine inverse of root of 1 upon 3. Substituting this in the calculator, so sine inverse of root 1 over 3, that is coming out as 0.6154. So we'll get 2x minus 0.333 equals to 0.6154. Now we have to be within 0 and pi over here. So, and as it's a square root, so we'll have both the positive and negative quadrant answers. So we'll make 0.6154 in the first quadrant. We'll make 0.6154 in the second quadrant as well. We can make it on the third and the fourth as well, as it's a square root. So we'll make it in positive and the negative quadrants. We also have to take in consideration that it's 2x, so we'll have to add all of the answers by 2 pi. But as the limit of theta is only between 0 and pi, we can just use these four values. So we'll get 2x is equals to 0.6154 plus 0.333, and then we divide by 2. So plus 0.333 divided by 2, we get 0.474. 2, and as to three significant figures, so this answer will be 474 only. And then our second answer would be 2x equals to 0. So first of all, this angle would be pi minus 0.6154. So pi minus 0.6154, that's equals to 2.526. So 2.526 plus 0.333, and then we divide by 2. So plus 0.333 divided by 2, we get 1.429. And to three significant figures, that would be equals to x is equals to 1.43. And then let's take the third answer as well. And if it comes within pi, that will also be part of the answer. So now this total angle would become pi plus 0.6154. So 3.142 plus 0.6154 and then we add 0.333, and then we divide by 2, and the answer is coming 2.054. Now, one thing to clear up over here is, and I had to check the answer out as well, and the only two answers were x equals to 0.474 and x equals to 1.43. And that was because initially in the question, the R value was also positive root 21, and this was also a positive value of root 7. Unless we whole square or take the square root of the equation, only in that case we will be considering the negative signs. As in this case, it was already given as root 7 and not plus minus root 7. So we'll only consider the positive values, and we'll only have these two answers over here. Now, if in a question you square root both the sides, in that case, you will have to take the negative signs as well for the negative quadrants. But in this case, we'll only take the positive values of sign, and the final answers will be x equals to 0.474 and 1.43. In question number 8, we have the position vectors of A and B. Line L1 passes through the points A and B, and we have to find the vector equations for the line L1. So in the first step, what we should know is that the vector equation of the line L1 is A plus lambda B, where A is the point on the line and B is the direction vector, and lambda being the constant. So to find the direction vector of the line, we'll find AB, which can be written as B minus A, or OB minus OA, that's the same thing. So the vector B is 5, 1, and 6, and A is 2, 0, and 4. So the direction would be 5 minus 2, 3, 1, and 2. And as we have to find a vector equation, so we'll write it in the vector form. We can use the point A, which is 2i plus 4k plus lambda, and the direction will be 3i plus j plus 2k. In part B, the line L2 has the given equation, and we have to show that the lines L1 and L2 do not intersect. So first we can write the line L2 in the form. So we can write it as 2 plus mu into 1 is mu, 1 plus mu into 2, so 1 plus 2 mu, and then 5 plus mu into 3 will be 5 plus 3 mu. And line L1 can be written in the parametric form as 2 plus 3 lambda, and then j is 0, so 0 plus lambda into 1 will be lambda, and then 4k, so 4 plus lambda into 2 will be 2 lambda. And the first step, what we'll have to do is we'll have to equate the, we know this represents x, this represents y, and this represents z. Similarly for L1 as well. So we'll equate the equations for x and y, find the value of lambda and mu. And when we substitute it into the z equation, if it does not come out the same, it means they do not intersect. So the first equation would be 2 plus mu is equals to 2 plus 3 lambda. 2 and 2 cancels, so mu is equals to 3 lambda. For the second equation, we can write 1 plus 2 mu is equals to lambda, or 2 mu minus lambda equals to 1. So mu is equals to 3 lambda, we'll get 2 mu minus, in place of mu, we can write 3 lambda. So this will become 2 into 3 lambda minus lambda equals to 1. And then this will become 6 lambda minus lambda is 5 lambda equals to 1. So lambda equals to 1 upon 5. Once we have the value of lambda is 1 upon 5, mu would be equals to 3 upon 5. And then substituting it into the equation for z, we will get for line L2, that is 5 plus 3 into 3 upon 5. That would be equals to 5 plus 9 upon 5. So the z value would be 5 plus 9 upon 5. That will be 34 upon 5. And for z, that would become 4 plus 2 lambda. So 4 plus 2 into 1 upon 5. That would be 4 plus 2 upon 5. That is equals to 5 4s are 20, and 20 plus 2 is 22 upon 5. As they are not equal, it means that they do not intersect. In part B, we have to find the acute angle between the directions of the line L1 and L2. So we have the direction for L2 as 1, 2, and 3. And the formula to find the angle is A dot B equals to A into B cos of theta. So the direction for line L2 is 1, 2, and 3. And the direction for line L1 is 3, 1, and 2. So you write it as 3, 1, 2 equals to, we'll find the magnitude of the first vector. So that will be 3 square plus 2 square plus 1 square. And it will be the same for the second vector as well. That would be 3 square plus 2 square plus 1 square into cos theta. So this will become 3 plus 2 plus 6 equals to, and this would be, this is root 9 plus 4, 13 plus 1, 14. So root 14 into root 14 cos of theta. So this will be 3 plus 2, 5. 5 plus 6 is 11 is equals to root 14 into 14 would be 14 cos theta. And finally, we'll get cos theta equals to 11 upon 14. So theta would be equals to cos inverse of 11 upon 14. Now substituting this in the calculator, we'll get shift cos inverse of 11 divided by 14. And the final answer would be 38.2 degrees. So the acute angle between the two direction vectors would be 38.2 degrees. And we can also give this answer in radian form as well. Question 9, the constant a is such that the integral of 6x ln x equals to 4 with the limits a and 1. We have to show that a is equals to exponent, so e to the power of whatever the function is. Now, in the first step, we'll integrate this function 6x ln of x. We can keep this outside. We can apply the limits at the very end. And we'll first integrate x ln of x and then put the limits and put it equals to 4. So when we have to integrate two different functions, we'll apply integration by parts and we'll use the late rule. So the log function is ln x. So u would be equals to ln of x and du would be equals to 1 upon x. Similarly, v dash would be equals to x. So v would be x squared upon 2. Now applying the formula for integration by parts is if we have u dv, so we get vu minus v du. Substituting this in the formula, so our u is ln of x and v is x square upon 2. So x square upon 2 ln of x minus v du. So v is x square upon 2 into du. So that would become x square upon 2 into x. That's 1 upon x. So x and x will cancel out over here. And not to forget, we still have a 6 outside. So we'll get x square upon 2 ln of x minus 1 upon 2 integral of x. And integrating x, we'll get x square upon 2 ln of x minus x square upon 2 again. When we integrate x, so we get x square upon 4. And then we multiply the whole expression by 6. So we'll get 3x square ln of x minus, and then 6 into 6 upon 4 would be 3 upon 2 x squared. And now we'll substitute the limits a and 1 and then put it equals to 4. So for substituting a, we'll get 3a square ln of a minus 3 upon 2a squared minus 3 into 1 is 1 into ln of 1 minus 3 upon 2 into 1. ln of 1 is 0. So we can get 3a squared ln a minus 3 upon 2a squared minus that will become plus 3 upon 2 and this term will become 0 equals to 4. Now we have to make, so a the subject and a square will be on the other side. So we'll first take 3 upon 2 on the other side and we'll get 3a squared ln of a minus 3 upon 2a squared is equals to 4 minus 3 upon 2. So 4 minus 3 upon 2, that will become 5 upon 2. And let's check if we have any 5 upon 2. So yeah, we have 5 over here. And then taking 3 upon 2a square on the other side, we get 3a square is equal to 5 upon 2 plus 3 upon 2a squared, and this is 3a squared ln of a. Continuing the working over here, we'll get, okay, so 5 plus 3 is 8 upon 2, that is, so 5 plus 3 a squared. Okay, and now we'll divide by 3a squared on both the sides. So we'll get ln of a is equals to 5 upon 6a squared plus 3 upon 3 and 3 will cancel. So when 3 divides by 3 upon 2 over here, this 3 and 3 cancel. So we'll get 1 upon 2, and a squared will also cancel out. So we'll just get 1 upon 2 over here. So we have 5 upon 6 and 3 upon 6. Yes, that will be 1 upon 2. So that's fine so far. And then finally, a would be equals to e to the power of 5 upon 6a squared plus 1 upon 2. And this is the same expression because over here 1 upon 6 has been taken common out. And if we take 1 upon 6 common out over here, we can write this as 5 e to the power of 1 upon 6. So this will become 5 upon a squared and plus 3. As 3 into 1 upon 6, that will become 1 upon 2. And yes, there was a squared over here. Okay, in part B, it says verify by calculation that a lies between 2 and 2.1. Now, the way to do that would be, we'll write the equation as a minus e to the power of 1 upon 6 into 5 upon a squared plus 3. And first we'll substitute and write it equals to 0. First we'll substitute a is equals to 2. So we'll write 2 minus e to the power 1 upon 6 into 5 upon 2 square, that is 4 plus 3. And we'll find the answer for this value. So this will become e to the power of, so 5, first let's do 5 upon 4 plus 3, that is 17 upon 4, multiply by 1 upon 6, that is 1 upon 24. So you'll get e to the power of 17 upon 24. And then 2 minus the answer, we are getting minus 0.0306. And then substituting 2.1, you get 2e 2.1 minus e to the power of 1 upon 6. And then let's do 5 divided by 2.1 squared, then plus 3 multiplied by 1 upon 6. Then exponential answer over here. And then 2.1 minus the answer, we get 0.108. So we get 5 upon 2.1 squared plus 3 equals to 0. Now this change of sign basically means that the root lies between. So we can just write change of sign from minus 0.0306 to positive 0.108 shows that the root lies between 2 and 2.1. And part C, we have to use the iterative formula based on the equation in part A to determine A correct to 3 decimal places. So we know that A can be written as e to the power of 1 upon 6 into 5 upon a squared plus 3. And then all we have to do is start off with the initial value. So the initial value we can take as the middle value of 2 and 2.1. So let's take 2.05. Now let's substitute this into the calculator. We get e to the power of 1 upon 6 multiplied by, and this will become 5. So we can write it in bracket form, 5 upon 2.05 whole squared, and then plus 3. And we'll close the bracket and we'll get 2.01. So this answer is coming, the second value is 2.01. And then in the same value, instead now we'll write 2.01 over here. And okay, so are we getting 2.026? And we have to give all of these to, okay, so one mistake, we have to give all of them to 4 decimal places. So 2.0 264. And we'll have to substitute this exact value into the equation again. So substituting this over here, we'll get 2.0264. I will whole square the equation and we'll get 2.019 now, 2.01968. So that will be 2.09197. And then substituting this back into the equation. So 0197, we get 2.022, 2.0224. And we have to give the answer correct to two decimal place. So we have to make sure we get our answer the same correct to two decimal place. So substituting this back again, we get 2.0224 and we get again 2.021. 0.0213, and let's do it one more time to make sure the answer is the same to the second decimal place. So 2.0213, and we are getting again 2.02175. So again we are getting the answer to two decimal places. So the final answer for A will be 2.02. In question number 10, in part A, we have to find the quotient and remainder when x cubed plus 5x squared minus 2x minus 15 is divided by x squared minus 3. Now, as we are dividing, we'll just write it as, so this will be x cubed plus 5x squared minus 2x minus 15 divided by x squared minus 3. In the first step, we will divide x cubed by x squared. We divide the higher powers. When we cancel out, we get x. X multiplied by x squared minus 3 will be x cubed minus 3x. We change the sign as we do in division. So this will become minus, this will become plus. This cancels out. We get 5x squared minus 2x plus 3x is plus x minus 15. Then we divide 5x squared by x squared. So we'll get 5x squared upon x squared. This cancels out. We get plus 5. So 5 into x squared would be 5x squared minus 15. Changing the signs over here, we get minus and plus over here. This cancels, this also cancels, so we get x. Now, as this has a lower power than x squared, so we'll stop over here and the remainder would be equals to x. And the quotient would be x plus 5. In part B, the variables x and y satisfy the differential equation as given, and y equals to 2 when equals to 2. So we have to obtain an expression for y squared in terms of x. Now, in the first step, whenever we are solving a differential equation, we'll bring the y term with dy. So we'll write it as 6y dy equals to x cubed plus 5x squared minus 2x minus 15 upon x squared minus 3, and dx comes over here. Now we integrate both the sides. Now before integrating, we know that this has been divided, and just for understanding, let's say if we divide 7 by 3, so we write it as 2 wholes 1 upon 3, which is the same as writing 2 plus 1 upon 3. So the quotient over here is x plus 5. So we can write this expression as x plus 5 plus the remainder, in this case that is x, upon the divisor, which is x square minus 3 dx equals to 6y dy. Now integrating 6y, we get 6y squared upon 2 equals to integrating x, that is x square upon 2 plus 5x. And as for integrating x upon x square minus 3, so what we have to observe over here is that the derivative of x square minus 3 is 2x. So if we multiply the equation by 2 over here and let's say divide over here by 2, we can write it as 1 upon 2 ln of x square minus 3. So the integral of x upon x square minus 3 would become 1 upon 2 ln of x square minus 3, and we add a constant over here. Now we know that when y is 2, x is equals to 2 as well. So we'll write 3 into 2 squared is equals to 2 squared upon 2. plus 5 into 2, that's 10, plus half ln of, that will be 2 squared. So ln of 4 minus 3, that is 1 plus c. Ln of 1 is 0. 2 square 4 times 3 is 12 is equals to, this will be 2 and 4 upon 2 is 2. So this will be 12 plus, so this is 0 plus c. So this also cancels, so the value of c is 0. So finally we'll get our expression as 3y squared equals to x square upon 2 plus 5x plus ln of x square minus 3 half over here. And then as we have to make y the subject, so we'll just simply divide by 3 on the right hand side. So y squared would be equals to x square upon 6 plus 5 upon 3x plus 1 upon 6 ln of x square minus 3 with the value of c being equal to 0. So that would be the final expression. In question number 11, the diagram shows the curve y equals to cos root sine 2x for 0 to half pi. The curve has a maximum point at m where x equals to a. In part A, we have to find the exact value of a. Now, what we know is that the maximum point means that the dy dx will be equals to 0. So, as the two terms are multiplying, we'll have to apply vu dash plus uv dash to find dy by dx. Now, we know that u is equals to cos of x. So u dash can be written as minus sine of x. And v is sine 2x to the power of half. So v dash can be written as half into sine 2x to the power of minus half multiplied by the derivative of sine 2x is cos 2x. And this, the derivative of 2x is 2. So that also multiplies uh, over here. So this will become 2 and 2 will cancel out. So the derivative of sine 2x to the power of minus half will become sine 2x to the power of minus half into cos of 2x. Now apply substituting this into the formula, what we'll get is vu dash, that will be equals to minus sine x into sine power 2x to the power of half plus uv dash. So u is cos of x into v dash is cos of 2x into sine of 2x to the power of minus half. Now simplifying this, first this, and we can write dy dx equals to 0 as it's a maximum point. Now taking this on the left hand side, we will get this as positive sine x sine 2x to the power of half equals to, and on the right hand side we'll have cos x cos of 2x, and we can write this in the denominator as sine 2x to the power of half. And it is important we put the bracket over here. Now when we multiply sine 2x half power half by the same, so what we'll get is sine of x into sine of 2x is equals to cos of x cos of 2x. Now simplifying this, if we'll bring it on the left hand side, so we'll get sine of x sine of 2x minus cos of x cos of 2x equals to 0. Now, if we compare it with the formulas given at in the formula sheet, we'll observe that this is the same as applying cos of a plus b, as cos of a plus b is equals to cos a cos b minus sine a sine b, and the only difference is, all right, so we could have just brought this over here as well, so we can rearrange it and write it as, we could have written this as cos of x cos of 2x minus sine of x sine of 2x equals to 0. And now when we compare it with cos of a plus b, this will be written as cos of x plus 2x. So this will be equals to cos of 3x, and that is equals to 0. Now 3x would be equals to cos inverse of 0. So cos inverse of 0. Now we know that cos is 0 when x is equals to pi upon 2. So we can say 3x would be equals to pi upon 2. If we substitute this in the calculator, we'll get pi upon 2. and x would be equals to pi by 6. So this would be the value of a, as this x value is referred to as a. So we can now say a would be is equals to pi by 6. In part B, it says that the region enclosed between the x-axis and the curve is rotated 2 pi radians about the x-axis. We have to find the exact volume of the solid generated. Now to find the volume generated, and if it is rotated about the x-axis, we write it as the limits. So the limits in this case are 1 upon 2 pi and 0. So we have pi upon 2 and 0. And the expression is cos of x into root sine of 2x dx. And we'll first whole square the expression and then add pi to the final answer. Now, first when we whole square, we'll get cos square of x into sine of 2x dx. Now to integrate this, for cos square of x, we can use the identity over here, and the identity is cos of 2x is equals to 2 cos square minus 1. So we can get cos of 2x plus 1 upon 2. So in place of cos square, we can write cos of 2x plus 1 upon 2. And this is multiplied by sine of 2x. So opening up the bracket, we can leave the 1 upon 2 outside. We'll get cos of 2x sine of 2x plus sine of 2x dx. Now, to integrate this expression cos of 2x sine of 2x, we can again use another identity, and that is sine of 2x is equals to 2 sine x cos x. And we can extend it to write it as sine of 4x is equals to 2 sine of 2x cos of 2x. So in place of sine 2x cos 2x, we can write sine 4x upon 2. So we can get sine 4x upon 2 plus sine of 2x, and we can just bring the 1 upon 2 later on. Now let's integrate sine of 4x, so that it will be minus cos of 4x upon 4. So 4 times 2 will become 8 plus, and this will become, so integrating sine of 2x will become minus cos of 2x upon 2, and then we'll multiply the whole expression by half. So what we'll get is minus cos of 4x upon 16 minus cos of 2x upon 4. Now, once we have integrated the expression, we can plug in the limits. The upper limit is pi by 2. So we'll get minus cos of 4 into pi by 2 upon 16 minus cos of 2 into pi by 2 divided by 4. And then, okay, so we have already multiplied by half. So we'll just apply the lower limit now. That is cos of 0 upon 16 minus cos of 0 upon 16 upon 4. So this will cancel out. We'll get cos of 2 pi, and cos of 2 pi, if we substitute this in the calculator, so I think that's equals to 1. So we'll get minus 1 minus cos of pi is minus 1. We'll just confirm it from the calculator. So cos of pi equals to minus 1. So this will become plus 1, as this is a minus over here. So this will become plus 1 upon 4 minus cos of 0 is 1. So this will be minus 1 upon 16. And again, cos of 0 is 1. So this will become plus 1 upon 4. So minus 1 plus 1 upon 4. So that will be, we'll multiply this by 4 when we take the LCM. So minus 4 plus 1 is minus 3 upon 4 minus, and simplifying this, we'll get minus 1 plus 4, that is equals to, so that will is equals to 3 upon 4. So minus 3 will be 6. So I'll get minus 6 upon 4. And as we have a modulus sign with the a volume or area, so this will be 3 upon 2. And finally, we can just add pi to the final answer, and the volume would be 3 upon 2 pi. And just one correction, on checking the answer, I found out that the answer is wrong because I did not take into consideration the 16 over here. So we'll have to correct this. Uh, so cos of 2 pi was minus 1, 1. So this would have been minus 1 upon 16. And this was plus 1 upon 4. So this multiplies by 4, this multiplies by 4, and so we get minus 1 plus 4, that becomes 3 upon 16 over here. So I don't know how I got 3 upon 4 over here as well, because the LCM was 16. So this is 3 upon 16 from this side, and this is minus, and so cos of 0 is 1, and this would have been a minus anyways. I don't know how I made this a plus as well. So this will become minus 1 plus 4, that will make it. So minus 1 minus 4 is minus 5. So minus 5 upon 16, and then finally 3 plus 5 would become 8 upon 16, which is equals to 1 upon 2, and then we add pi to the final answer. So the final volume would be equals to 1 upon 2 pi. Thank you.